In this lesson, we're going to be looking at simplifying negative radicands, and in particular, we'll be dealing just with square roots. So what's going to happen is that in many of our problems, we'll have something that looks like this. We'll have the square root of, let's say, negative 9. Okay? And so what you want to do is deal with the fact that this radicand, and remember the radicand is the part of the radical that's under the square root. So the radicand here, I'm using the word radicand, is negative 9. So I am dealing with a negative radicand. Now, I just want to remind you that when I take the square root of a negative 9 on the calculator, just to remind you, so I want you to look at this. So the square root of a negative 9, and you'll notice that you get a domain error. All right, so remember, the square root of a negative number, the square root of a negative number is not a real number. And so that's where we started talking about the idea of imaginary numbers in previous lessons. And so in all of our problems, we're going to be looking at radicals in which the radicand is negative. Okay, so what we need to do now is review our basic definition. So remember, by definition, we defined the square root of a negative 1 to be the imaginary unit I. All right, so that's something you got to remember. You have to know that the square root of a negative 1 is defined to be I. And so we're going to use this quite often. So I'm going to write the words down, the word know here. So I need for you to know this. So the square root of a negative 1 is defined to be the imaginary unit I. We looked at that in a previous lesson. Now also, if I square both sides, square root of a negative 1 equal I. So if I take these two sides and I square both sides, so again, if I square both sides, I'm going to go ahead and square this side, and I'm going to go ahead and square this side. And so I get the square root of a negative 1 squared. Now remember, the square and the square root undo each other, so I end up with negative 1 on this side. And on this side, I have I squared. So by definition, I squared is equal to negative 1. So these are the two things I need for you to remember for this lesson. All right, so I is defined to be the square root of a negative 1, and then I squared is equal to negative 1. Okay? All right, so the directions for the problems will probably look like this. It will say, perform the indicated operations and then write the result in standard form. And so in previous lessons, we looked at the word complex number. So let me remind you that a complex number in standard form is this. It's A plus BI. And so in our examples, for many cases, you'll write the answer as this. So it looks something like this. So it looks like 3 minus 4i, something like that. So that's what I mean in to write your answer in standard form. Okay? All right, so let's look at number 1. So number 1, we have this. We have the square root of a negative 81 minus the square root of a negative 16. So the square root of a negative 81 minus the square root of a negative 16. Now the way I would approach this is this. So I would look at each little part here. So I have the square root of a negative 81, so go off to the side and rewrite this using some of our rules. And so the square root of a negative 81 I can write as the square root of a negative 1 times the square root of 81. Okay? Now most of you already know that the square root of a negative 1, you can tell me what that is right away. Some of you may have to do this, and that's fine. So the square root of a negative 1, remember, is defined to be I. That's one of these things I asked you to remember. And so I get I, and we know that 81 is a perfect square, and so the square root of 81 is 9. So I get I times 9, which is 9i. So whenever we write imaginary numbers or terms that involve the imaginary unit, we tend to put the coefficient in front. So always write it as 9i. Always put the I in the back. And so this right here is 9i. So I get 9i, and then you're subtracting, and then you do the same thing with square root of a negative 16. So again, at some point, I'm not going to keep writing this part here, because you can look at this and see that the square root of a negative 16 is 4i. Now be careful. It is not negative 4. It is not just 4. It is 4i. So sometimes students, they do things so quickly, and they're not really thinking about what they're looking at. So remember, this right here means the square root of a negative 1 times the square root of 16. And so the square root of a negative 1 is I, okay, and the square root of 16 is 4, okay? All right, so then this becomes 4i. Now, these two terms right here, 9i and 4i, and I'm subtracting those two terms are like terms because they both contain the imaginary unit I. All right, so all I have to do is just say 9i, and I'm taking away 4 i's, and so I end up with 5i. It's kind of like I'm going to go ahead and do this on another sheet of paper. It's kind of like if you had this idea from previous lessons. Okay, so it's kind of like when you had, let's say, 7x minus 3x. So now these are variables, whereas this right here is an imaginary unit, but it works the same way. So I have 7x's, and I'm taking away 3x's, so you're left with 4x's. These were like terms. Remember the word like terms. And so when we look at this right here, these two are like terms. Right? And so I have 9 i's, and I'm taking away 4i, you're left with 5i. And so there's your answer. Now, keep in mind that the directions did say write the result in standard form. So if you left it like this, that's fine. Okay, but I want you to notice that you can also write it as, remember, A is your real part, and then the BI is your imaginary part. And so A in this case is 0. So this would be 0 plus 5i. Okay, so either one's fine though. So you can write it as 5i, or you can say 0 plus 5i. Does not matter. So in terms of multiple choice, this may be an answer, or this could also be an answer. Okay, so let's look at number 2. So number 2, we have this in number 2. We have 3 times the square root of a negative 25 plus 2 times the square root of a negative 100. All right, and so it's kind of using this idea here. So we know if you kind of cover up that coefficient 3 here, we know that the square root of a negative 25 is 5i, so I get 3 times 5i plus, and then over here do the same thing. So remember, this right here means 2 times. So that's going to be 2 times, and then the square root of, if you think about this, the square root of a negative 100, remember, is the square root of a negative 1 times the square root of 100. And so this is I, this is 10, so I get 10i. All right, so that'd be the first thing I would do. Then I would go ahead and remember that, hey, 3 times 5 is 15, and then 15 times I is 15i. And over here, 2 times 10 is 20, and so I get 20i. And now, just like we did this one, so these are like terms, and so 15i plus 20i is 35i. Or you can write your answer as 0 plus 35i. All right, number 3. Okay, number 3, we have negative 7 times the square root of a negative 4 minus 5 times the square root of a negative 9. All right, so same thing we did here. So you're gonna kind of look at this as 2 separate factors. So you're going to say this can be negative 7 times, and then over here, be a little bit careful. This is not the square root of 4, because the square root of 4 is 2. This is the square root of negative 4. And so remember, the square root of a negative 4 is the square root of a negative 1 times the square root of 4. And by definition, the square root of a negative 1 is I, and the square root of 4 is 2, so this becomes 2i. You're subtracting, so write this down, subtracting 5 times, and then what's the square root of a negative 9? Well, the square root of a negative 9 is 3i. Okay, and now let's go ahead and multiply this out. So a negative 7 times 2 is a negative 14, and a negative 14 times I is a negative 14I. Subtract. 5 times 3 is 15. 15 times I is 15I. Okay, now some of you still have a little bit of difficulty dealing with signed numbers. So if you look at this, you remember you can always change subtraction to addition. So if you need to do that, you do that. So you can say, all right, well, I know that this is subtraction, and I know that I can change the subtraction by adding the opposite. Okay? And so I get negative 14I plus the opposite of a positive 15I, which is a negative 15I. So this right here, so subtracting 15I means the same thing as adding a negative 15I. And then now, some of you may not remember your sign rules for adding or subtracting sign rules, but here you're adding two terms whose signs are the same, so you add their absolute value and you keep the sign. Many students, though, since you have access to a calculator, you just go ahead and you say, remember you got to look at your coefficients, so you say negative 14 plus, and then this was negative 15, and you get negative 29. So this becomes negative 29I, or you can say 0 minus 29I. Okay? All right, so that was number 3. Okay, let's look at number 4. All right, so number 4, we have this. Now, number 4 is going to look a little bit difficult, and that's because you have all these square roots in there, and you have negative radicands. So it makes things a little bit harder to deal with, but let's just kind of look at it. Now, the way I would do this, and remember, you have two terms here, you have two terms here. So I want to remind you that, and I'll go ahead and do this right here. So I'm going to write this as reminders. So one of the things I need to remind you is that when you multiply two binomials, 3 plus 5x times 2 minus, let's say, 6x, when you multiply two binomials, one of the methods you can use is the FOIL method. And so you would say first times first, so the first term of each binomial, so 3 times 2 is 6. The outer, 3 times negative 6x is a negative 18x. The inner, 5x times 2 is 10x. And then the last, 5x times a negative 6x, 5x times a negative 6x is a negative 30x squared. And then you combine like terms, so your outer and your inner here were like terms. They both contain the variable x. And so you got 6 minus a negative 18x and a positive 10x is a negative 8x, and then minus 30x squared. Okay? So just remember the FOIL method, and so that's what we're going to use here. So when I look at number 4, this is what you see. You have two binomials times, a binomial times a binomial. So 2 terms times 2 terms. Now what you want to do first is before you use the FOIL method here, let's simplify that negative radicand. So in other words, this becomes 3 plus, all right, now think, what's the square root of a negative 36? So right away tell me, the square root of a negative 36 is 6I times, all right, same thing here, 2 minus, what's the square root of a negative 49? 7I. And you see it looks a little bit easier to deal with. So that's the way you want to do this. You want to rewrite this without the square root if you can. So these were perfect squares. The square root of 36 and the square root of 49. 36 is a perfect square, so the square root of 36 is just going to be 6. 49 is a perfect square, and so the square root of 49 is 7, because 7 times 7 is 49. 6 times 6 is 36. Okay? Now let's go ahead and use the FOIL method. All right, so remember, F-O-I-L. So first, outer, inner, last. So first means you take the first term of each binomial and you multiply them, because this is what you're doing. This is multiplication right here. This times this. 3 times 2 is 6. The outer, the terms on the outside, 3 times a negative 7i is a negative 21i. The inner, a positive 6i times a positive 2 is a positive 12i. And then the last, a positive, first of all, notice this is a positive 6i times a negative 7i. So a positive times a negative is a negative. 6 times 7 is 42. Now be careful. I times I, okay, I times I is kind of like in previous courses when you had something like x times x. So what's x times x? Well, remember, you multiply like bases, you add exponents. 1 plus 1 is 2, so x times x is x squared. Okay, so if you had x to the third power times x to the second power, remember, when you multiply like bases, you add exponents. So this would be x to the fifth power. 3 plus 2 is 5. So these are all reminders from previous courses that are needed when dealing with this particular lesson. Okay, so remember, so I times I is I squared. So you got to say I squared here. Don't forget that. That's important. That's I squared. It is not I, it is I squared. I times I is I squared. Okay? All right, let's combine like terms. So these right here are like terms. So let's go ahead and deal with that. So I get 6. And again, if you can't do this in your head real quickly, and just be on the safe side and use your calculator. So you have negative 21 plus 12. So negative 21 plus 12 is negative 9. Okay? So this becomes 6 minus 9i minus, all right, now here's how we deal with this. See that negative 42i squared? So I would say negative 42. Now remember, I squared, that was one of the things you had to remember. So remember, I squared is defined to be negative 1. Okay? So I'm going to rewrite this as negative 42 times a negative 1. That's what I squared is. So at this point, this is where you want to rewrite I squared as negative 1. And now this becomes 6 minus 9i. And then remember, you can think of this as a negative times a negative. Even though this is subtraction, remember you can always rewrite subtraction as an addition problem, so adding the opposite. So a negative 42 times a negative 1 is a positive 42. And so you have, now let's combine like terms. So these constants are my like terms. And so let's put it in a plus bi. So we're going to put the constant first, the real part first. And so 6 plus 42 is 48. So I get 48 minus 9i, and there's your answer. Okay? So just go back and notice that you're using a fold method, and so the first thing you want to do to get to this next step is simplify the square root of that negative radicand. Okay? And then you go from there using the fold method. Another thing you got to remember is that I times I is I squared. And then I squared is equal to negative 1. Okay? All right, so let's look at the next one. So this would be number 5. Now, number 5, we have negative 3 plus the square root of a negative 64 squared. So notice that this is a binomial squared. Two terms squared. Okay? So remember what that means, though, is that this binomial that's being squared, I can write it as that binomial times itself, right? That's what this means right here. And now this looks like our number 4. So we have a binomial times a binomial, so I can use the fold method to help me to multiply this out. And so we get negative 3 plus the square root of a negative 64. Remember, 64 is a perfect square. So the square root of a negative 64 is 8i, right? Don't forget the I. You're taking the square root of a negative number. So remember, the square root of a negative 64, square root of a negative 64 means the square root of a negative 1 times the square root of 64. Okay? And so the square root of a negative 1 is I, square root of 64 is 8, so we get 8i. Times, and do the same thing here, negative 3 plus 8i. All right? Now, always remember that when you square a binomial, when you rewrite it as a product of two factors, they're both the same, right? Because you're squaring that binomial. Okay, so let's use the fold method. Okay, so first outer inner last. Negative 3 times a negative 3. A negative times a negative is a positive, so you get 9, right? The outer, a negative 3 times a positive 8i is a negative 24i. The inner, a positive 8i times a negative 3 is a negative 24i. And before I go on, I just want to remind you this. Whenever, if you go back to what you've learned in previous courses, when you square a binomial, when you multiply polynomials in previous courses, when you square a binomial, the outer and the inner are always the same. So always keep that in mind. If you have something squared, if these two factors are the same, these two binomials are the same, then these have to be the same term, okay? All right, and then the last, now remember, always be careful with the last because you have I times I here. So 8, a positive 8, so look at the last now. So we did the inner, that was this one. So we have 8 times 8 is 64. I times I is I squared. So always be careful with that. I times I is I squared, okay? And now let's go ahead and rewrite things. So I have 9. These are like terms, so a negative 24 and a negative 24. Again, if you are having difficulty, use your calculator. But a negative 24 plus a negative 24 is a negative 48. So I have negative 48i. And then rewrite this. So it'll be plus 64. Now here's what I would do. Circle the I squared, because you know that I squared is equal to negative 1. And replace that with negative 1. So you get 64 times negative 1. And now I get 9 minus 48i. A positive 64 times a negative 1 is a negative 64, right? And so now let's put this in the form a plus bi. So notice that these are constants, so I can combine those. Those are like terms. And so 9 and a negative 64 is a negative 55. And again, if you have trouble, you say 9 plus a negative 64 gives me a negative 55. Okay? And then minus 48i. And there's your answer. So you wrote this in the form a plus bi. All right, so that was number 5. Okay, let's do another one like this real quick. So let's do number 6. So number 6, we have negative 4 minus the square root of a negative 121 squared. So negative 4 minus the square root of a negative 121 squared. Okay, so again, let's go ahead first of all and simplify this negative radicand. And so this becomes 4 minus, and remember, the square root of a negative 121, right? So the square root of a negative 121 is going to be the square root of a negative 1 times the square root of 121. And the square root of a negative 1 we know is defined to be I. And then 121 is a perfect square. So what times itself is 121? 11. So this becomes 11i. Okay? And so now we're going to rewrite this as 4 minus 11i times itself. And so let's go ahead and use the FOIL method since I'm multiplying two binomials. So I get 4 times 4 is 16. The outer 4 times a negative 11i is a negative 44i. Now remember, you're squaring a binomial, right? So what do you remember about the outer and the inner? The outer and the inner should be the same. And it is, because look, a negative 11i times 4 is a negative 44i. All right, now be careful when you do the last. A negative 11i times a negative 11i. So a negative times a negative is a positive. 11 times 11 is 121. And then I times I is I squared. Okay? All right. So I get 16. Well, let's combine these. A negative 44i and a negative 44i is a negative 88i. And then over here, we're going to get plus 121. Now remember, I squared is negative 1. So write this negative 1. Okay? And so we get 16 minus 88i. And then a positive times a negative is a negative. So a positive 121 times a negative 1 is a negative 121. And so I get, now let's combine like terms. So 16 and a negative 121. So use your calculator if you need to. 16 plus a negative 121 gives me negative 105. So you had negative 105 minus 88i. And that's all you do. There's your answer. So you wrote this in the form a plus bi. All right, so that was number 6. Okay, now let's look at number 7. So number 7, we have something like this. I just before we go on, let's remind ourselves about this. So this will be another reminder. So let's do this right here. So I want to remind you this. So remember in the past, in a previous course, when you multiplied square roots. And so let's say you had the square root of 3 times the square root of, let's say, 5. All right, so as long as the as long as the indexes are the same, so remember square root, so this index, if you don't see it, is understood to be a 2. So as long as the indices are the same, then you can write this as as 1 square root. And all you had to do is just multiply the radicands together. 3 times 5 is 15. Okay? And so the rule was this. So we had the square root of a times the square root of b. Then you can rewrite this as the square root of the product of the radicands, ab. Now, you have to be careful with what we're about to talk about. So that's what you learned in the previous course. All right, and notice that in previous course, the radicands were positive. All right, so since the radicands were positive, this property held up. Okay, now we also know this, that if I have the square root of 3 times the square root of a negative 5, this property still holds. It still holds. So this becomes the square root of a negative 15, right? And so this would be, so remember the square root of a negative 15 would be I square root of 15. Okay? So that property still holds. But here's the thing I want you to be careful with. Okay, be careful with this. All right, so listen carefully. What if they were both negative? So in other words, what if this was the square root of a negative 3 times the square root of a negative 5? Okay? I want you to know that this property no longer holds. This property does not hold. So if you use this property right now, so this property does not hold for when they both negative, okay? Because watch, if you make this mistake and you overgeneralize this property right here, you would say, hey, so that's going to be the square root of a negative 3 times the square root of a negative 5, and so that's the square root of 15, right? That's not true. That is not true. Because I want you to see this. We have the square root of a negative 3 times the square root of negative 5. So if I use what I learned in previous lessons in this course, the square root of a negative 3 is defined to be I square root of 3, right? Because look, the square root of a negative 3 is the square root of a negative 1 times the square root of 3. So that's I square root of 3. Times, and over here, this is the square root of a negative, oops, let me go ahead and redo this way. So here, the square root of a negative 5 is the square root of a negative 1 times the square root of 5. And remember, the square root of a negative 1 is defined to be I, so it's I square root of 5. And so this would be I square root of 5, right? Okay, so notice that you're multiplying all these factors, I times the square root of 3 times I times the square root of 5. Multiplication, remember, multiplication is commutative. The order in which you multiply does not matter. So in other words, if I say I times I, that's I squared, right? And then the square root of 3 times the square root of 5 is the square root of 15. Correct? Okay. But what do we mean by I squared? Well, I squared is defined to be negative 1. So this is negative 1 times the square root of 15, or negative square root of 15. And that's the answer. So notice it is not the square root of 15 is the answer. So when I multiply a square root of negative 3 to the square root of negative 5, I don't get square root of 15. This property only holds, or let me rephrase it. This property does not hold if they're both negative. Okay? It holds if they're both positive. It holds if one of them is negative and the other is positive, but not both. So be careful. When you're multiplying square roots, you have to be careful with your radicands. You got to think, okay, are they both negative? Is one negative? Can I use this property? Can I not use this property? All these things, okay? All right, so I just wanted to remind you about some parts here. Some parts is kind of new now because I did talk about this right here, what happens when they're both negative, okay? All right, so we're going to use this idea in this problem now. Okay, so this is number 7. Let's suppose I had this. I had the square root of, let's say, negative, let's make it easy first. Let's say square root of a negative 16 times the square root of a negative 25, okay? So based on what we just learned, in this part here, okay, we know that I cannot say a negative times a negative is a positive. We know that because we know that this property right here only applies if both are positive, if A and B are both positive, or if one's positive and the other one's negative, but not both. So when you get to that point, the way I would do this is I would say, all right, let's look at this first. Square root of a negative 16 is 4i times, and then the square root of negative 25 is 5i. And now this becomes 4 times 5 is 25. I times I is I squared. And I know that I squared is a negative 1, right? And so this becomes negative 25. And so that's your answer. Okay, so be careful. The answer is not, I'm sorry, not 25, excuse me. 4 times 5 is 20, right? So 20. So the answer is not 20. The answer is a negative 20. So be careful. Okay? All right. Now, let's look at this for a moment. So let's remind ourselves about reducing, and I'm going to go ahead and do this as a reminder. So in the previous course, some more reminders. Okay, so in previous course, you had to simplify radicals. Now notice 20 is not a perfect square, but remember what you did in the previous course. So first of all, since 20 is not a perfect square, there is no whole number. Whole number times itself, that's 20. 4 times 4 is not 20, 5 times 5 is not 20, 6 times 6 is not 20, and so on. Okay, so this radicand 20 is not a perfect square, but remember, you always ask yourself, can I simplify this? And so that was one of the topics you learned in the course last semester. Can I simplify this? So you're looking for a perfect square that goes into 20. And so the largest perfect square that goes into 20 evenly is 4. So I can write this as square root of 4 times the square root of 5. And so the square root of 4 is a perfect square, so that's why you use a perfect square. So always use the largest, because if you use the largest, then this should, the only perfect square that should go into this radicand would be 1, okay? And so this becomes 2 square root of 5, and so that'll be your answer there. So that's how you would simplify this. All right, so this is a review from a previous course, and so we're going to use this idea with some of our problems now. All right, so let's look at this. So this is number 8. So number 8, let's suppose we had this. We had negative 9 minus the square root of a negative 32 divided by 18. So when we get into using the quadratic formula, this is going to look familiar. And so if I look at the square root of negative 32, so let's look at that first, square root of a negative 32, I know, remember, just like we were doing before, I know I can write this as the square root of a negative 1 times the square root of 32, okay? I know that the square root of a negative 1 is defined to be I. Now, remember, 32 is not a perfect square, but you got to ask yourself, can I simplify the square root of 32? Is there a perfect square that goes into 32? And there is. 4 goes into 32, right? But 4 is not the largest. Always, always use the largest. It helps you. It helps you with some steps. And so this right here, square root of 32, let me go ahead and write this here. Square root of 32 is the square root of 16 times the square root of 2. 16 times 2 is 32. And 16 is the largest perfect square. So this becomes 4 square root of 2. And so right here, I'm going to say I times 4 square root of 2. All right. Now, let me remind you about this, or let me tell you about this. You see how I have I times 4 square root of 2, and I have a square root in this part here? We tend, and so it's always a good idea to put I in the middle. Put I in the middle. Always put the square root on the end. So we get 4I square root of 2, and that's how we prefer to write it. Okay? All right, so this is going to go here. So I get negative 9 minus 4I square root of 2 divided by 18. All right, now, remember the direction said, always follow the directions. The direction said write in standard form. Write in standard form. And so when I put this in standard form, I'm going to get negative 9 divided by 18, subtract 4I square root of 2 divided by 18. Okay? So remember, your denominator is just one term right here. So negative 9 divided by 18 minus, and then 4I, this term, divided by 18. Now you got to simplify. So this term, they're both divisible by 9. So this becomes negative 1/2 minus, and then over here, the 4 and the 18 I can reduce. They're both divisible by 2. So this becomes 2I square root of 2 divided by 9. 4 divided by 2 is 2. 18 divided by 2 is 9. And you cannot simplify any further, so there's your answer. So this is the form A plus BI. Okay? All right, so let's number 9. So number 9, let's suppose we had this number 9. So it would be another one just like we just did. So let's say we had this instead. 6 plus the square root of a negative 18 divided by 15. All right, so let's remember what we did. So you're going to see this again pretty soon when we talk about solving quadratic equations. So right here, let's pull this aside and let's think about this. All right, so I have the square root of a negative 18, okay? And I know that I can write this as the square root of a negative 1 times the square root of 18. And then I know that the square root of a negative 1 is defined to be I. Now 18, though, is not a perfect square. There is no whole number times itself, that is 18. But I can still simplify the square root of 18 because the largest perfect square that goes to the 18 is 9. So I get the square root of 9 times the square root of 2, right? And so the square root of 9 is 3, so this becomes I times 3 times the square root of 2. And remember how we write it? We tend to put the I in between the whole number part and the square root part. So this becomes 3I square root of 2, and that goes here. So this becomes negative 6 plus 3I square root of 2 divided by 15. Now remember the direction said write in standard form. Okay? Write in standard form. So I got to rewrite this as two separate fractions. So I get negative 6 divided by 15 plus 3I square root of 2 divided by 15. Okay? But I can simplify this. So if you can simplify it further, you need to do that. Okay? So if you left it like this, you would get most of your points, but you wouldn't get all of it because you didn't simplify each part. So let me go ahead and rewrite this so I don't mess this part up. So I'm just going to go ahead and rewrite what we have. Now here's what I mean by simplify. If you look at the 6 and the 15, even though the fraction is negative, let's look at this in terms of 6 and 15. The 6 and 15 are both divisible by 3. They have a common factor of 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. So it becomes negative 2/5. Okay? And then over here, same thing. 3 and 15, the common factor, the largest common factor is 3. So 3 and a 3 is 1. 3 and a 15 is 5. So I get 1I square root of 2, which is just I square root of 2, divided by 5. And so that's the form, that's your standard form, A plus BI. Okay? All right, so that was number 9. And then real quickly, let's just kind of do this. Let's do number 10. So we have number 10. So number 10, let's suppose we had this, the square root of a negative 20 times the square root of a negative 3 minus the square root of 5. Okay? All right, so notice that this is one factor times a expression that has two terms. So just kind of reminder, let's do another reminder. So in terms of another reminder, remember when you had something like 3x times 2x plus 5? So when you multiplied polynomials, this was a monomial and you had a binomial, and so you just distributed. And so you'd say 3x times 2x is 6x squared, and then 3x times 5 is 15x. Okay, remember that? That's what you're going to do here. You use that same idea. So here you use a distributive property. And so you can do the same thing. You can do the same thing here. So you can distribute. But before you do that, let's deal with those negative radicands. Okay, so you always do that first, so you don't mess up. Because remember, if I cover this up right here, and you say a negative times a negative is a positive, you know that property does not work, right? So you got to be careful. Always, before you multiply square roots in which the radicands are negative, always rewrite it using I first. Rewrite it using I, okay? All right. So in other words, what I would do first is this. Go off to the side and look at what we have. So I have the square root of a negative 20. So I know that the square root of a negative 20 is I times the square root of 20, okay? Well, I should have said this first. So the square root of negative 20 is the square root of negative 1 times the square root of 20. So that's I square root of 20. Now let's go ahead and simplify the square root of 20. If you can't always simplify this square roots, but here we can, because what's the largest perfect square that goes into 20? Well, it'll be 4. So I can write this as I times the square root of 4 times the square root of 5, because 4 times 5 is 20. And so the square root of 4 times the square root of 5 is the square root of 20. And then the square root of 4 is 2, so this is going to become right here 2I square root of 5. And so that's what I'm going to put here. So I'm going to put that here. So it's 2I square root of 5 times. All right, let's talk about the square root of a negative 3. So the square root of a negative 3, remember, it's the square root of a negative 1 times the square root of 3. And so the square root of a negative 1 is I. This is I square root of 3. Now, ask yourself, can I simplify the square root of 3? Besides 1, is there another perfect square that goes into 3? No. So I cannot simplify this. So I'm going to put this here. So it'll be I square root of 3 minus. And then notice this radicand that is positive, so I'm just going to rewrite it just like this. Okay? All right. Now, I know it still looks complicated. You may say it looks even more difficult. Yeah, but at least you won't make that error where you're going to say a negative times a negative is a positive, because you know that these are this product of two square roots only apply if the radicands are both positive or if one's positive, one's negative, not both negative. Okay? So at least you know you won't make that mistake if you do this first. So let's go ahead and distribute. Okay, now let's be careful. What I would do is I would kind of write some things up because there's a lot of stuff going on here. So I would say, all right, so this is 2I square root of 5 times I square root of 3, right? So that's what this is. So this times this is this. And so, and remember, these are all products. So the multiplication is commutative. The order in which you multiply does not matter. So I times I is I squared. We know that, right? And then the square root of 5 times the square root of 3 is the square root of 15. And then all I have is 2. So I get 2I squared square root of 15. And I know that I squared is a negative 1, correct? And so 2 times a negative 1 is a negative 2, so it becomes negative 2 square root of 15. Now, can I simplify the square root of 15? Is there a perfect square other than one that goes into 15? No. So this times this is this. So you see, it helps if you go off to the side and kind of do your work. So this is going to be negative 2 square root of 15. All right, and let's do this one. So now we're going to say this times the square root of 5. So do the same thing here. So you go off to right here and do it. So 2I square root of 5 times a square root of 5, right? Okay? Okay. Now, so a positive times a negative is going to be a negative. So I'm going to be subtracting, right? Okay, now let's do this. Okay, so I have 2I. Now remember, the square root of 5 times the square root of 5 is the square root of 25, correct? Write it out. Okay, do the steps. And then the square root of 25. 25 is a perfect square. So what's the square root of 25? Well, the square root of 25 is 5. So 2I times 5. And then remember, multiplication is commutative. So the order in which I multiply does not matter. So I could say 2 times 5 is 10. And so I get 10I. And so this right here, when we say this times this, we get 10I. And so there's your answer right here. Okay? And so just be a little bit careful. See how I did this. So it can get pretty messy. So your thought processes need to be managed as best as you can. So do the steps in different parts away from your process that you were going through here. Okay? All right, I want to do one more because you may see this in my math lab. So let me do this. So this is number 11. And so number 11, I have 6 square root of negative 11 times negative 2 square root of negative 27. Okay? All right, now let's deal with the negative radicands. So I know that square root of a negative 11, so this can be written as 6I square root of 11. Okay? Because remember, the square root of negative 11, if you have to, write it out. See how I'm doing? Do that. Some of you don't have to, some of you will. So this becomes square root of a negative 1, square root of 11. And so this is I square root of 11. So that's what you saw here. Okay, over here, now let's look at the square root of a negative 27. Square root of a negative 27. So that becomes the square root of a negative 1 times square root of 27. And the square root of a negative 1 is I, it's defined to be I. But remember, 27 is not a perfect square. But what perfect square goes into 27? You use the largest, and that's 9. So this becomes the square root of 9 times the square root of 3, because 9 times 3 is 27. And the square root of 9 is 3. So this becomes I times 3 square root of 3, or 3I square root of 3. And so that's going to be this right here. So I'm going to say negative 2 times, and then this right here is this. So 3I square root of 3. Okay? All right, now let's look at this part right here. We know that negative 2 times 3 is a negative 6, right? Okay, so let's do that. So this is 6I square root of 11. This is negative 6I square root of 3. Okay? All right, now be careful. So this is not a binomial. Think of this as a monomial right here. Okay? And this is a monomial. So basically all your operations, if you look at all your operations, it's a product. So 6 times I times square root of 11 times negative 6 times I times the square root of 3. And remember, multiplication is commutative, so the order in which you multiply does not matter. So what that means is this: 6 times a negative 6 is a negative 36. I times I is I squared. The square root of 11 times the square root of 3, square root of 11 times the square root of 3 is the square root of 33. And I cannot simplify the square root of 33. But I can simplify this I squared. So I squared is a negative 1, okay? And so negative 36 times a negative 1 is a positive 36, square root of 33. All right, so there's your answer. Now, if you want to write it in standard form, also another way to write this is by saying 36 square root of 33 plus 0I. Okay, so you don't see an I right here, right? So you just say 0I. But either one's fine. So both of those in terms of writing in standard form would be correct. All right, so that was our lesson on multiplying negative radicands.